Okay, so welcome back. Happy Thursday. Today we are going to finish up section 8 and then cover all of section 9. Tuesday is some new stuff, and then on Thursday, 1 week from today, is quest number 2. Quest number 2 is coming up on Thursday, 1 week from today. Looks like the quest covers, slightly off the screen here, quest covers lessons 6 through 9. That means that, so 6 we covered right before the first quest, and then 9 we are covering today. So the quest is a week from today. Today is the last day of new stuff on the quest. We're going to move on Tuesday, but the things we do Tuesday will not be on the quest. Clear? Okay. All right. I thought we might do things just a little bit differently than we normally do. Typically, we would have finished section 8 would just be, hey, pick up wherever you left off. I'll remind you we were doing scatter plots last class and drawing lines of best fit. But that is so closely related to the stuff in lesson 9 that I thought maybe we would just jump in with lesson 9 right now. It will be a good refresher for how to find equations of lines, which will help you in 8. And then you'll have a big old chunk of time to do the activities, finishing from 8 and starting and finishing from 9. So I think that's what we'll do today. One quick announcement, actually 2 quick announcements. First of all, is one quick typo here at the top of this page. Can you guys jump real quick to 71? It says a copy machine, and then there's supposed to be the word worth. Top of 71, number 3, a copy machine is worth $8,925. Just put that word in there. Okay, everybody has the correction here? Okay, so then let's go back to 67. We'll take a look at our daily summary at the top of 67. In this lesson, we use real-world data to find equations of lines. We then use our equations to solve problems. This looks an awful lot like what we did last class. The only difference today is that we're just going to be given 2 data points. There'll still be a context. It'll still come from a word problem, but we'll just be given 2 points, and we'll find the equation of the line that connects them, and we'll use that equation to answer some other problems. Whereas last class, we were given a bunch of points, 6 or 8 or 10 points, and then we drew a line that we thought was close to all of them. But this one, we should all be getting the same answers because we are given only 2 points, and we're all going to find exactly the same line. All right, that's the only difference. Number 1. According to a report in USA Today, sales for personal breathalyzers have spiked in recent years. The CEO of Wintergreen Research reported that the 2009 personal breathalyzer market was valued at $215 million. I'm going to pause right there because I feel like there's some data that I'm going to end up using. In 2009, $215 million. Somehow those 2 things are related to each other. And continuing the sentence, up from 28 million in 2005. That feels like another piece of information. 28 million is associated with 2005. Got those 2 data points. We'll assume sales are growing at a constant rate. That is, they keep growing at the same rate every year. And we'll use the figures to predict the value of the personal breathalyzer market this year, 2015. Part A, define the 2 variables for the situation. Identify which is independent and which is dependent, including units. Let's give this a shot. If time is involved in a problem, like in this one, 2009 and 2005, then it is always which variable, dependent or independent. Time is always the independent. Time marches along. It could care less about anything else that is happening, including the breathalyzer market. But as a result of time passing, the breathalyzer market changes. So our independent variable is time in years. That's our unit. Since, and then so that we don't have to plug in literally the number 2009, let's just rescale it. Can we just scale it to 2000? Is that easy enough? Since the year 2000, is that all right? Yep. Okay, and then the dependent variable, I guess, is the other one. It involves money. What word would you use to describe the dependent variable? What are we measuring? The market value or the value, so say market value. In, what are the units here? So we could say dollars. If we say millions of dollars, then we don't have to write a lot of zeros. Let's do that. Millions of dollars. And it says the breathalyzer sales information provides us with two ordered pairs that fit our variables. What are they? Include the units for each variable when writing the ordered pairs. So here we go. First ordered pair, let's go with the yellow information. Which one comes first, the 2009 or the 215 million? 2009, because we said time was the independent, that's the x, that's the first variable. So should we put 2009 as the first coordinate? Remember we said since 2000, so we rescaled everything. So 9. And then what's the y value, which is the market value? 215, and the million is already covered by our description. Okay, go ahead and write the other ordered pair. I highlighted that one in blue. So what do we have in this one? 5, 28. Oh, I didn't follow my directions. What did I forget to do? Units. Okay, let's include some units. That 2009 was 9 what? 9 years. And that 215 was $215 million. I'll just put a dollar sign in the front. Same thing on the other one. Years and $28 million. Okay. And now we've got two ordered pairs, and this problem is pretty much removed from the context of the breathalyzer market. We're going to find the equation of the line that connects those 2 points. We have to start by calculating what? Slope. So let's calculate slope. So upstairs, 215 minus 28. Subtract the y's. Downstairs, 9 minus 5. So what is that, 187, I think? Okay, and oftentimes in application problems or word problems, decimals are more manageable than fractions. So that goes in how many times? 4675, sounds good. That's fine. Okay, and now we get to start writing our equation. So we'll do y equals mx plus b. 4675 is what? M, so I'm copying everything else. Y equals 46.75 x plus b. And then we'll plug in. You could pick either point if I have a choice and one of them involves smaller numbers. I'm picking that one every time. So I'm going to pick 5 and 28. So which one becomes the y? 28 equals 46.75 times how much? Times 5 plus the b. Somebody with a calculator help me out here. 200, 230. How much? Thank you. And then we'll move that over and get b equals what? 205.75. Great. Negative 205.75. And so that means that our final equation is y equals 46.75x minus the b we just found. Okay, 205.75. Okay, so there's our equation. Y equals 46.75 minus x minus 205.75. And now that we've got our equation, we're going to use it down here in part B. It says, interpret the meaning of the slope in this context and write a sentence in plain English. For me, I can't interpret slope until I have units. 215 and 28 we're measuring in what units? Millions of dollars. So let's go ahead and throw dollars up here on top. And that 9 and that 5 were measured in years. So dollars on the top, years on the bottom. It's got to be the same units here, even if it's not a fraction anymore. I can make it a fraction. And we've done this many times now. When we're interpreting slope, that division line changes to what word? Per, right? Slope is always something per something. So in this case, dollars per year. So apparently something was changing by about $46.75 million per year. What was changing? The market value. And was the market value increasing or decreasing? Increasing. Somebody else? Why is it increasing? How can we know? Because the slope was positive, right? We know positive slope means increasing. So there's our sentence. The market value was increasing by $46.75 million per year. Okay, and then finally part E, predict the value of personal breathalyzers that will be sold this year, 2015, and interpret your solution by writing a complete sentence. Is this 2015 one of the input variables, the independent ones, or the dependent output? It's an independent, right? This is a time. Are we going to literally plug 2015 in? What number are we plugging in? Just plain 15 because we started the clock at 2000. So all we're doing is using that green equation right there, but we're changing the x, the input value, to 2015. So we'll try that. Y equals 46.75 times 15 minus the 205.75. Anybody have a number for us? $495.5. Okay, and then the last thing here just said write your answer as a complete sentence. Now there was a question like this on the Quest, and some people wrote down something about like, you know, well, I took the 2015 and I converted it to just 15 years, and then it was 46.75 per year, but then we had to subtract the y-intercept. I don't need your life story as you write the sentence, all right? This is a simple sentence. It just needs to have two numbers in it, the input number and the output number. What's the input number? 2015. What's the output number? 495. That's all. You just got to write a few words around those numbers and you've got a full credit sentence. Somebody want to give it a shot out loud here? Someone be brave. How's that sound? Value of personal breathalyzers will be $495 in 2015. Yeah, there's just one extra word I was looking for, and that's million, right? So 495 is our answer here, but in the context of the problem, it's million. Okay, so any variation on either of those sentences sounds good. 2015. the breathalyzer market. Will be $495.5 million. Okay, so like I said, we're trying things a little bit differently today than we normally do. We're going to see how this goes, but we have until 1:40, which is 1 hour and 22 minutes or so from right now. This is the last thing I'm going to say to you. So the next hour and 22 minutes is you guys doing activities. Here's my recommendation. I know we didn't finish from last class, but because we're all in the same place right now, but last class we ended in different places, why don't we just continue here? So in your groups, you're going to start on the activity 2 pages away. You're going to get through all the activity. You're going to go through the even more practice. Then you're going to go back and you're going to do all the scatter plot questions from lesson 8, okay? And when you finished all that, we'll find some good problems in the practice packet for you to do. Raise a flag if I can help.